Good morning, everyone. Today I'm here to present about our project, Predictive ICU Monitor. My name is Siranjit of Group PC. So let's dive into it. So, Predictive ICU Monitor is an AI-powered system designed to enhance patient safety in ICUs by addressing critical issues of alarm fatigue. Like, for example, in today's ICUs, we rely heavily on vital sign monitors. However, these traditional systems often trigger alarms based on static thresholds for individual signs. This leads to several problems, such as first, they're reactive. Alarms often sound only after a patient's condition has already significantly declined, and they also cannot understand complex patterns, and they also produce most highly noisy data. So we have came up with a solution which is proactive, intelligent, and monitoring. So our predictive ICU monitor aims to shift this reactive alarm to predictive prediction and intelligent interpretation. So in this whole project, we have divided it into two stages. Stage one is early detection with machine learning and clinical interpretation with generative AI. When machine learning model predicts high risk, we don't just send another beep. Instead, we package the relative data into a JSON format. So let's dive into it. Next, the dataset strategy. So we are using a API key which is public, like called as vital DB, and it consists of all the vital sciences which we needed for this project. And for the second layer, which is generative layer, we are using Google Gemini LLM, which can help us in giving us a complete English sentences, so that the nurse can understand what the error is and what the alert is. Next, the predictive pipeline. As I've said, as I said before, our stage one will first detect the anomaly in the vital signs. Then it will package the whole data at that timestamp as a JSON format to the LLM, which is Google Gemini. And this Google Gemini will interpret the prediction, and then the prediction is displayed through Flask and Socket IO. Next, our model's performance. In the, for our model, we used a window size of about 120 minutes with interval of 1 minute per update. So, and our accuracy is up 92 to 95, and the model is also working extremely well. Next, key perform highlights. The first thing about this idea is that it is a robust, and the idea itself, when trained with higher quality data, will also significantly boost the accuracy and performance. Next, seamless LLM integration for interpretability. Due to this integration, the the model can also effectively communicate with the nurse, and through and the this whole setup is scalable for multiple patients simultaneously. Next, tech, tech stack. So for our project, we are using Flask, Socket.io, and Python for backend. For ML, and in stage one we are using XGBoost, and for stage two we are using Gemini's LLM. Next, for front end, we are using HTML, CSS, JS, and Chart.js for charting, and utilities are Python, .env, .env, .venv, and etc. Next, key features. The main features of our project is that it predicts sustained hypertension before onset, and it also generates natural language insights. And due to these insights, the nurse can easily identify the issue and can react accordingly. And real-time visualization of vitals and risks. This will help greatly in a real-world scenario. Interactive alerts, and whenever the response LLM gives a response to the nurse, she she or he need to mark it. Then only the alarms will stop. Else the alarms will just keep on bombing. As such, it will also alert the nurse if she is not aware of the situation. The whole project is lightweight, deployable, and scalable for ICU environments. Next, clinical impact. For the clinical impact and benefits. For the main point of this, the main Shama. Clinical impact and benefits. In this slide, I'm going to explain about the what is clinical impact and benefits. Unlike the standard traditional case where we are using a static thresholds, we are in we are using dynamic pattern matching, due to which there are cases such as hypertension, sepsis, etc., which can be found earlier compared to compared to the traditional method where the situation may be too late and the damage may have been done. Next, data-driven insights. Our data analysis found that multiple vital signs are analyzed carefully, like heart rate, respiratory rate, SpO2, etc. Feature trends detect subtle psychological decline and also higher relation between HR, and MRP. Next, future roadmap. We are also, if possible, we are also planning to implement RAG, and if we found a better quality data set, then maybe we can increase its performance by retraining. And finally, we are deploying. Next, conclusion. So the main point of this project is to create a predictive AI-powered ICU monitoring system capable of identifying deterioration faster than using standard thresholds. So why it matters? First thing is that it saves critical time in ICUs. Like when the alert is given, then there is a small delay between the alert and the response time. If the alert itself is given late due to these thresholds, then there is a huge impact on patient's life. It also reduces cognitive load on citizen and demonstrates the intelligence of the monitoring. Next, so this is our code for our project. Early detection saves lives. Predictive AI makes it possible. So next thing, I'm going to now show a small demo on our project. So as you can see, this is a small demo which shows the working of our project. So let's start the simulation. In this case, I'm passing a small data set containing the important vitals such as heart rate, MAP, respiratory rate, SpO2, etc. So as you can see, the graphs are charted based on the timestamps, so that whenever the nurse is alerted, they can also check the recent chart, and can identify the problem if possible, if needed. And as you can see, this got it got a little bit stuck here. See, as you can see, the assessment is given by the LLM, and the nurse has to click the acknowledgement. So this is how our model works. And in case there are a repetitive alerts, then then there is a dynamic snooze button, which is given, so that the nurse can hold it. Like for example, see this, a snooze button is given here. So if I directly try to snooze it, it's not possible. I have to snooze it through here only. And when I have to acknowledge the message given by LLM, then only I can snooze it. This is the demonstration which I've prepared. So through in this way, our model will help nurses to identify the deterioration or changes in vitals quickly, so that they can act as soon as possible.